Welcome back to another video. So we are going to discuss about wave shaping circuits. So different electronic devices need different types of waveforms. It is sometimes necessary to generate one waveform to another waveform. For example, I'm going to use a sine wave and some application I need to convert the sine wave to square wave, or sometimes the square wave is converted to a triangular waveform. So different kinds of this transition is required in communication field. So many signal processing systems need wave shaping circuits basically, such as differentiating, integrating, clipping, clamping, all these purposes. So different purposes of wave shaping circuits. If you ask application for wave shaping circuit, we can write differentiator. We can write an example as differentiator. Second one is integrator. So differentiator circuit will do basically the differentiation of mathematics, and integrator will do the same as integration function. And we have two more applications like clipping, and the second one is clamping. And we can say slicing. Different applications are these functions are done on the signals. So clipping, in a sense, some portion of the signal will be removed, and clamping means it will do the DC level adjustment. So these are the different applications of wave shaping circuits. Now we will talk about in depth about the wave shaping circuits. So these wave shaping circuits can be classified into basically two. So you can see here it is classified into two basically. One is linear wave shaping circuits, and the second one is non-linear wave shaping circuits. So what is linear wave shaping circuits and what is non-linear wave shaping circuits? In linear wave shaping circuit, we are designing this circuit with respect to R, that is resistor, L, that is inductor, and capacitor. So the circuit can be made with respect to or make use of these passive components. This is called linear wave shaping circuits. For example, we have combinations like RC linear wave shaping circuits that we are using resistor capacitor combinations, and we also have RL, that is resistor inductor combinations, and we have RLC, which make use of resistor inductor and capacitors. Which in turns, if you talk about non-linear wave shaping circuits, we can able to create wave shaping circuit using resistor, inductor, and capacitor. Alongside, we use diode and transistors. So this is called non-linear wave shaping circuit. So we are additionally using uh, components like semiconductor components like diodes and resistor in the circuit, and that kind of circuit is called the non-linear wave shaping circuit. So the purpose is same, where linear and non-linear wave shaping circuits are used to shape the waveform. Okay, but it has only passive components like RLC, which is called linear wave shaping circuit. And if you are using diodes and transistor combination along with RLC, which is called the non-linear wave shaping circuit. So and we are going to discuss a linear wave shaping circuit first. In that, we will focus on RC wave shaping circuits. RC linear wave shaping circuits basically. So this is RC linear wave shaping circuits because RC comes under linear wave shaping circuits. Okay, so we will discuss that first. So RC circuits we classified into two. We have RC low pass. So we have these two classifications like RC and low pass filter. So these are the two basic configurations like RC, RL and RLC, and this RC is classified like we can categorize into RC low pass filter and RC high pass filter. And RC low pass filter we have the analysis, and then we go for RC low pass filter as an integrator, and then RC high pass filter as an differentiator. So this is analysis, and also we will look into uh, how different waveform behaves to RC low pass filter and RC high pass filter in